In this section, we're going to talk about the angle bisectors of a triangles. We distinguish angle bisectors from perpendicular bisectors by recalling or remembering that perpendicular bisectors bisect the sides of a triangle, whereas angle bisectors bisect an angle. So here the angle bisector ray XY is highlighted in yellow. The angle being bisected, which is angle LXM, is divided into two congruent angles, which are angles LXY and YXM. So the theorem says if a point is on the bisector of an angle, so which is point Y, if it's on the angle it is equidistant from the two sides, so it will be equidistant. The important thing to remember is that when we talk about the distance from a point to a line, it must be the shortest distance, which means it has to be the perpendicular distance. Look at the right angles at L and M. So if segment X, or rather ray XY bisects angle LXM, and segments YL and YM are perpendicular to sides XL and XM, then YL equals YM. This is useful in measuring distances or finding distances. The converse of the angle bisector theorem states that if you have a situation where you're given that these distances are congruent and Y is a point on ray XY, then the only way that can happen is if ray XY is an angle bisector. So we say if segment YL is perpendicular segment XL and segment YM is perpendicular to ray XM, and that and is important, YL equals YM, then ray XY bisects angle LXM. And you'll see how we'll use this in problems later on. The concurrency of angle bisectors. So let's look at this diagram. These are angle bisectors, so we'll mark those. Those are congruent. 1, 2, 3, 1, 2, 3. So we've noted that these are angle bisectors. If they intersect, not if they intersect, they always do intersect at point P, which is always inside the triangle, then that point P is equidistant from the three sides. So we can notate that by showing now this. EP and PF will be the same measure. Not only that, you'll see in the next sketch that PE, PD, PF are the radii of the circle that is inscribed in this triangle. Okay, the point of concurrency of the three angle bisectors of a triangle is called the incenter of the triangle. The incenter C, and let's highlight it here, this incenter C always lies inside the triangle. So a circle can be inscribed with the incenter as the center of the circle, and the radius is the distance between the incenter and the side. So the radius is this red segment that I'm going to highlight in blue here. So this would be the radius, and the black segment from C to vertex is just part of the angle bisector. Let me just go ahead and notate that, so that's the angle bisector. And there'll be two other angle bisectors as well, which I haven't drawn. So let's apply our newly founded knowledge to these problems. So let's see, what do we see here? First thing we see is an angle bisector because I see these two angles that are marked congruent. So I know that because this is an angle bisector, YL is going to be equal to YM. So if you go ahead and work that problem out, and I'm going to leave room here, you'll see that YL equals 14. So go ahead and finish that problem and check your answer. Okay. Here, if we look at the diagram, we see we are not told, or we can't see from the diagram that XY is an angle bisector. However, we can conclude that because we see that Y is equidistant, and the equidistant is because of these red congruency signs. So because it's equidistant, therefore we can say that the angles are equal in measure. So I could set 6x equals 3x plus 15, and if I go ahead and solve it, I will get x equals 5, and the angle will be 30 degrees. So x will be equal to 5, and measure of angle MXY will be 3 times 5 plus 15 degrees, so it is 30 degrees. You should check that for yourself. In this example, we are given that point P is the incenter. So very quickly, what we need to figure out, what does that mean? It means that it is equidistant from the 3 sides. So this is what I mark my diagram with. The other thing is that PF is 3 and PB is 5. So we need to find PE. Well, since that's the radius, that's very easy. That will be 3. And instead of saying find CE, let's say find BF. Okay? How would we find BF? Do you see a right triangle in there? I think I do. The right triangle is PFB. Apply Pythagorean theorem, work it out, and I believe BF should be equal to 4 units. So make sure you work all the problems out so that you come to the answer that I have written over here.